You know what? It would help if I turned on my microphone. It's a good thing this is the last episode. That way I don't have to be embarrassed about whether future episodes I will continue to make mistakes, because this is my last opportunity to make all of the production mistakes possible. That's right, folks. Live from Earth. It's Space Radio. I'm Paul Sutter, astrophysicist at Stony Brook University and the Flatiron Institute. In the next half hour, the last half hour, your agent to the stars. I got an amazing show for you today, where it's all questions all the time. It really is going to be a good time. I mean, what a way to go. What a way to go. This show has lived for 4 years on listener questions. This is your last chance to get your voice on the air. You can go to spaceradioshow.com. And there's a little button there. You can drop a voicemail. I'm doing all remaining voicemails tonight. That's it. We're doing voicemail roulette, which we all know what a hoot that is. It's also your last chance to join the Space Cadets. I mean, if you're listening to this in the future, then it's already too late. But if you're listening to it in the present or in the past, somehow, if you're listening to this in the past, we got to talk. Or maybe we needed to talk. Not sure about how verbs work with time travel. But you can get on now. Go to spaceradioshow.com to get the links for the Twitch and YouTube live streams. That's spaceradioshow.com. We've got Space Cadets tuning in live from around the world, including but not limited to Orange County, California, Ohio, Chicago, Texas, Pell City, Alabama. What else? I did San Juan, Puerto Rico. Who else we got? Lancaster, Ohio, Waverly, Iowa, Howell, New Jersey, Alamo, California, another Columbus, Ohio checking in, Denham Springs, Louisiana, Redmond, Washington, London, UK, Ottawa, Canada, Washington, D.C. Who else? Is it another Ottawa, Canada, another London, UK? Yes, I know I'm muted. I know, I'm not muted anymore. Austin, Texas, who have some free ICU beds if you need it. Accrington, UK. Jackson Heights, New York City. Idaho Falls, Idaho. And yes, my family is on. My brother, my mom, my uncle. They're all chatting because they all know me. Parma, Ohio. Denver, New Orleans, Kolkata, India. Oh, fantastic. And if you're on Facebook, sorry, I don't have my Facebook stream up right now. This is going to be a different show. Usually I try to stick to a half hour. We do a little bit of news. We do 1 or 2 voicemails. Then we do the Space Cadets, and it's all a good time. Now, this is definitely going to be all a good time, but I'm just going to go. I'm going to go until there are no more questions. Seriously, until we're done. This show started, for those of you who don't know, this show started almost exactly 4 years ago. And it started over in Columbus, Ohio, where I was living at the time. And I was having a lunch with the executive director of WCBE Radio 90.5 FM, an NPR affiliate in Columbus, and he said he was looking for new shows. And so I created this show, this idea called Space Radio, where we do a little bit of news. And the main idea was going to be a call-in show, like traditional, old school. Hi, I'm on the air. You call in. You talk to me. We have a conversation. We had a whole voicemail or like a whole phone system set up. It was all super fancy, and it was a disaster because nobody called in ever. So I would just sit here for a half hour just talking to myself because no one would call in because it was a brand new show. And so we eventually ditched the phone system. We were finally able to go live stream, and there were so many iterations. We were building the airplane as we were flying it. We were able to go do a show live stream, and I came up with the voicemail system. So you leave a voicemail and then you play it. That works so much better. and then questions. I know I miss it. I miss Columbus too. Columbus, well, I mean, not that much. I did move, and I'm not moving back, but Columbus was a great city. Columbus was good to me. WCBE radio. If you happen to live near Columbus, check out their program. They're still doing amazing. Dan Michalko, by the way, was the executive producer. And then I moved to New York, like 2.5 years ago. So halfway through the show's run, we still continued with WCBE radio. I'd record in New York, but it would still air on Columbus. About a year ago, we ended that, decided to go 100% pure live streaming. And also at the same time, I got the cheese sponsor, Dom's Cheese, domscheese.com, who has provided a year of cheese. I've almost cleared out their case. I could have gone 2, maybe 3 more episodes until they would have ran out of cheeses, and I would have had to repeat. Nobody wants that. So that's the real reason why the show is ending. And by the way, as I am rambling, I want you to send in your space questions right now, and I will get to them. This is what I'm doing. I am rambling, doing a little bit of buffer here so you can get your questions in so we can get right to the science, which is why we're all here. Just kidding. We're all here for the cheese. And incidentally, we also learn about how the universe works. And Dom's Cheese has been a fantastic partner. I really, really encourage you. They're a fantastic, amazing cheesemonger. They have very good taste. I know because I sampled all of their cheeses that they picked, and they're all amazing, except for the Yay Toast that I had last week. I told them about that. It's like, I was not a fan of the Yay Toast. And they're like, yeah. I don't think they sell a lot of Yay Toast. I don't think it goes bad. I think we could put it in a box and bury it in the ground, and then 10,000 years from now, they will excavate this region of Connecticut, and they will open it up, and that Yay Toast will look exactly the same and probably taste exactly the same. A lot of you have been asking, why is the show ending? Which is a good and valid question. And like all things that end, there is more than one reason why things end. One is primarily I'm almost out of cheese. And we're not going to do repeats on this show. We don't do old stuff. We always want fresh. We always want new. And Dom's Cheese is running out of cheese. The other reason is my life is getting much more complicated in a very, very beautiful and very fun way, with lots of exciting personal stuff and lots of exciting professional stuff, lots of exciting projects. And it's hard. I've noticed over the past 6 months, it's beginning harder and harder, especially as we attempt to dig out of COVID, to carve out this time every Thursday. If you've noticed, if you've paid attention, I don't know if you noticed or pay attention or not, I've had to cancel a lot of episodes. We've had to do a lot of skips, either for a family event or vacation, or I'm traveling or doing a work project. And like, it's hard to make this consistent Thursday night. And so I was feeling, starting about 6 months ago, that I was not doing the right thing to the audience. I wasn't serving you right by being consistent, by doing a show every week, by being here for you. I feel like I was being inadequate. I wasn't living up to your expectations that you never expressed to me, but I still was not living up to them. And in terms of projects, Space Cadets, you're awesome. You always have a place in my heart, right next to the plaque buildup from all the cheese. And you're awesome. All of my other projects, my podcasts, my YouTube, my recorded YouTube videos, Ask a Spaceman videos, articles, just grow and grow and grow, which is fantastic and beautiful to see all these people falling in love with space and science and how we know things. Space radio is not. I was never able to get a sponsor. Dom's Cheese is fantastic, but I was never able to get a financial sponsor for this show, unlike my other work where there are sponsors coming in. And so it's like, when I look at my time and how I divide my time, and I look at what I do uncompensated, what I do for sponsorship base, what I get paid to do, my bandwidth for the stuff that is purely free, that I don't get any money for, shrinks and shrinks every month. And so I just decided it's the end of the line for space radio. Now, There are new things coming online. Unfortunately, I can't talk about most of those because either the contract hasn't been signed yet or the contract has been signed and then there's all sorts of secrecy stuff until it actually comes out. But I can tell you a project that I'm very excited about is with Ars Technica, you know, the big nerd website, Ars Technica. We are creating a video series. We're filming it here in New York. It will be out at some point in the relatively soon future. We're beginning production next month. But that's all set. The train has left the station. We are making that. So it's a video series exploring the biggest mysteries in the universe. It's going to be so much fun. So I'm really looking forward to that project. This kind of live Q&A, the Q&A spirit. If you want the Q&A spirit, I encourage you to go over to TikTok, where I've started a presence on TikTok, tiktok.com/PaulMattSutter. And there's a button where you can ask questions and then I will make video answers. So it's like a bite-sized version of Space Radio. If you're not on TikTok, the TikTok stuff also gets blasted out to Facebook and Instagram. So make sure you follow me on those channels. And so you can still get that Q&A like, man, I got a question. I've got a bar bet that I need to settle. I know, ask Paul. Get out your phone, go on TikTok, hit the Q&A, type in a little question, and then you're good to go. Other projects, what else? Another season of How the Universe Works will be coming out. We filmed that last month, and that will be coming out next year. There's some other TV projects in the works. They're very, very exciting. There's some more digital projects. Interviews. If you liked how I was interviewing guests, there is a project in the works. I can't say with who, unfortunately, because the contract isn't signed yet, but we are developing it where it's an interview show where I interview other scientists and mostly ask them about cheese and odd questions about their personal life. Now, we've got so many voicemails. We've got so many questions from the Space Cadets. SAHM, let's get personal. This is the last episode. I usually don't answer personal questions because it's not that kind of show. But if you need relationship advice tonight, I'm here. We're just going to keep going until it's over. So if you're having trouble with some relationships, if you need some astrotherapy, my good friend Nick DePalma coined that term. He called it what I do, astrotherapy. Zero Skull, yeah, get on TikTok. All the kids are doing it, and then now you can just let the Chinese government know exactly what you're doing. Oh, and the book. Thank you, Larry. So I have 2 books out, Your Place in the Universe and How to Die in Space. There's another book, A Sickness in Science, Problems with Modern Science and How to Fix Them. That is coming out next year. I'm working with it's in editing, it's in review, it's moving along. It's moving along slower than I would prefer. I would have liked for the book to be out already. I finished it last February. But the publisher I'm still with them, and hopefully it's going to come out soon. I'm hoping for spring, at the latest summer or fall, and that book will come out soon. And just follow my website, follow me on social media so you know exactly what I'm doing post Space Radio. But anyway, this personal question, what is your genealogy / ethnicity? I'm mostly Slovak. Good old Slovakia, some Swiss German up in there, some Welsh and Irish and English of the old school kind. I did find out, I did the DNA test. I am 0.5% Ashkenazi Jew. Other than that, Slovak and Swiss German, that's my thing. And now, AR West on YouTube, red dwarfs, solar flares emitting from the poles, not the equators, better chances for life on their planets. Okay, there's this very interesting thing. The majority of stars in our galaxy are red dwarfs. Ergo, the majority of planets in our galaxy are in orbit around red dwarfs. So if you're looking for life by the raw numbers, it's probably going to be around a red dwarf, not a sun-like star, because that's where all the planets are. That's where all the potentially habitable planets are. That's where all this stuff is. But red dwarfs are notorious for getting brighter and dimmer, throwing off massive flares, and it just gets nasty really, really quickly. So if you're on a planet orbiting a red dwarf star, you're going to get blasted all the time, which is very frustrating when you're trying to, say, develop multicellular structures. However, there have been some recent observations that maybe red dwarfs preferentially emit their flares out of the poles. Honestly, we don't know enough about red dwarf. These are the small stars, by the way. Red dwarf flares on the statistics of that in order for us to make a good comment on the potential for life. That's all I got to say about that. Nancy, hey, Nancy. By the way, Nancy has been fantastic. Mega dittos. No, wait, wrong show. Wrong show. I grew up having to listen to Rush in the radio. Hi, Mom. Thank you for that. Mega applause for Nancy for wrangling the Space Cadets every single week. I really appreciate that. When I sit down to read a book, who or what do I read? So I generally read 2 or 3 different kind of genres. When I just want to switch my brain off and have a good ride, I get some good sci-fi. I just have an adventure in my mind. I don't pay attention to the physics. I'm not doing anyone's homework, okay, I'm not consulting unless I'm getting paid for it. So I just enjoy a good sci-fi book. I'm a huge history nerd. I love reading about history, history blogs, history podcasts, history books. So I've got I just finished reading, I posted about this, The Light Ages, a history of science in the Middle Ages, a surprising history of science in the Middle Ages, and how really scientifically minded and advanced and inquisitive and ingenious Middle Age people in the Middle Ages were, and what we consider the Dark Ages were actually nothing but. So yeah, I love reading history nerd stuff. Infinite Monkey, is the participatory anthropic principle taken seriously by many physicists? I'm not sure what the participatory anthropic principle is, but the regular. Oh, do I ever read The Expanse? Sure. Yeah. When's the new season coming out? It's December, right? Read the books, loving the series. Expanse is great. Oh, I mean, the physics is horrible, but I don't watch or read sci-fi books to do the physics. I can read that in a physics textbook if I want, or I can just think of it in my own brain because I'm a physicist. Anthropic Principle, this is like, we're here because we're here. And if the universe were why is the universe this way? Because if it were different, we wouldn't be here. The only way we could be here is if the universe is this way, so therefore it's this way. It's not taken seriously by physicists because it's not a physical theory. It's a great philosophical idea and a great way to start that conversation and have those kinds of arguments and debates, but it is not a physical theory of the universe. Constellation Pegasus, last question. I don't believe it. Do you think white holes exist? What's the probability? No, they don't. White holes do not exist. Just stop. Oh yeah, I'm excited for our foundation, Larry Beckham. Foundation dropping tomorrow. Good to know. I should get around to doing Apple Plus, shouldn't I? Oh gosh. It's like having cable again, like spending $100 a month on all these streaming services, but it's worth it if I get to watch Foundation. I'm also excited to go see Dune. Anyone wants to see Dune with me? I need someone to see Dune with me in October. I used to watch the David Lynch version on tape again and again and again and again. Maybe I still do. White holes don't exist. They just don't. They don't exist because they are fantastically, incredibly unstable. You have a white hole. White holes are the opposite of black holes, where nothing can get in, everything goes out. But they still have gravity. They still have gravitational attraction because they're a massive object. What happens with white holes is if there's a little particle floating out here, and it's like, oh, look at that white hole. I'm gonna go check it out, and it gets gravitationally attracted to it. Because it can't go in, it just gets closer and closer to the boundary, and the energy of that system, if you add up all the total energy of the system, it increases. And as it approaches the event horizon of the white dwarf, it can never cross through, the energy goes to infinity. In other words, the moment you even look at a white dwarf, it blows up. And things that are that unstable in nature don't exist. 3-body problem, I do need to read it. I do need to read it or listen to it. It's been on my list forever. I heard so many good things about it. I do need to do it. Let's play some. Oh, wait. Before I do voicemail roulette, Zero Skull from Ohio sent me an email. Wanted to get some questions in before we started this, before we forgot them. So I'll do your questions and then we'll go to the voicemail and then maybe we'll do some cheese while we keep doing this. Asteroids or space invaders? Asteroids. It's played on a torus. Asteroids is played on the surface of a donut because you can go around to the sides. You can also go up and down. It's a mapping of a two torus on a donut, by the way, for all the math nerds out there, which is pretty much all of you. Question 2, what is the difference between a black hole and a very massive Bose-Einstein condensate? Black hole is literally a singularity. All the material is collected into an infinitely tiny point. A Bose-Einstein condensate is when you take a bunch of particles and cool them down so that they start to share a unified quantum state. It's not necessarily about the pressures or the densities there. It's about it's more about temperature there and about arranging the right quantum state. Question 3, if Pac-Man were a cheese other than cheddar, what kind of cheese would Pac-Man be? He'd be Swiss. Would a Carrington event likely induce a Kessimer event, especially in light of Elon Musk putting up Starlink? Like if we were to have a massive solar storm where all of our satellites would glitch out, generally our satellites are hardened against even the worst solar storms. They can go into shutdown mode. They can orbit for a while, and then we can turn them back on and do all the station keeping. Question 5, can you say, oh, it's a tongue twister. Ready? Charlie is cherry when choosing his cheeses, so cheese is a challenge when Charlie arrives. But Charlie is charming and chooses a cheddar, then chills it and chips it and chops up some chives. You're welcome. Thank you for doing the show. Thank you for all the amazing questions. Zero Skull from Columbus. Let's do some voicemail roulette. I will reload this page. Oh, boy. Here we go. This is always fun.
G'day, Dr. Paul. I was wondering, what are the limits to radio interferometry? Would the many small dishes of citizen scientists spread over the globe have any chance of useful or meaningful results?
This is a really fun question. I'm going to delete this voicemail. Thank you, V. So that was a good question. That was a good way to start our roulette this week. Radio interferometry. Here's the deal. The bigger the telescope, the better. Always. You bigger dish, more collecting area, higher resolution. It's all awesome. After a certain size, you start to run into some challenging engineering issues. Like it becomes difficult to build telescopes bigger and bigger and bigger, have bigger and bigger dishes. With radio in particular, and a couple other wavelengths, we found a way around this. Instead of building one giant dish, you can build lots of small ones and spread them out. And then the distance between the furthest pair of dishes gives you incredibly high resolution. So you just put those elements further away and you can get smaller and smaller details on the sky, which is great. What you miss out on is some of the coverage area because you have photons coming in from the sky. If they hit one of your dishes, you're golden, you get some data. If it hits dirt, you can't collect that. So there is a trade-off for that technique. And what makes interferometry work, what you need to do in the back end is very exquisite timing because you need to know when light from a distant source, you need to know when it hits the different elements of your interferometer of all those separate different dishes. And you need to know precisely when. You need to know those differences in timings as accurately as possible because that's what you use to reconstruct the signal. It's that difference information. So if you just have a random, a bunch of car antennas sitting around, it's very, very difficult unless each antenna has an atomic clock attached to it in order to reconstruct the image. So yeah, but this is the principle. This is how we got that great black hole picture, was through an interferometer with elements on opposite sides of the planet Earth and very, very accurate record keeping of the time between them. Here we go.
Hi Paul, Steve here from the UK.
Steve.
I recently learned that, in theory, the Big Bang should have created equal quantities of matter and antimatter, but 1 part in a billion of matter survived the subsequent mutual annihilation, and why that happened is something of a mystery. I've solved this problem, and I was wondering if you could recommend a good hotel in Stockholm where I can stay when I collect my Nobel Prize. My question, though, is this. If it had been antimatter which had predominated, would the universe be basically the same, or would it be fundamentally different in some way? Oh, and my solution to the matter-antimatter puzzle is that there were black holes at the beginning of the universe, and more antimatter fell into them than matter. Will my Nobel Prize notification arrive by letter, or should I check my email? Thanks, Paul.
Okay, first off, the latest announcements of the Nobel Prize in Physics is October 5th. They call you. Somehow they get your phone number. They talk to people who know your number and they call you. So on October 4th, you wait, and then they get a bio and everything. Don't worry. They'll call you, so just hang out by your phone. By the way, your plan doesn't work. The black holes, why would they preferentially eat antimatter rather than matter? Why does that asymmetry exist? The truth is, exactly as you point out, we don't understand the difference. We don't know why there's more matter than antimatter in the universe. But to get to your question, our universe, if it were completely antimatter, we would just call that matter, and then we'd call the matter antimatter. Doesn't matter. Wouldn't change any physics at all that we would recognize. It's just we would just call it matter. Here we go.
Yes, Paul. I saw you had another article about antimatter stars, and it got me thinking that if there can be stars, there can be antimatter black holes. So it made me wonder what happens when a star of matter goes into an antimatter black hole, or vice versa, or if an antimatter black hole and a regular black hole collide, what happens then? And particularly interested in what might happen gravitationally, if that would have a gravitational wave with a unique signature or something like that. Thank you.
All right, so this is the antimatter show. This works for me. Check this out. Once you fall into a black hole, it doesn't matter. It doesn't matter. Black holes will eat anything, and from the outside, 2 black holes. If I had a black hole, they ate a bunch of matter, and a black hole that ate a bunch of antimatter. The only difference would be their electric charge. That the black hole that ate matter, actually no, scratch that, because antimatter, because I'm completely wrong, because if one ate electrons, the other ate positrons, and then it also ate antiprotons, and then protons over here, it all balances out. It doesn't matter. Black holes, it just doesn't matter. It doesn't matter what a black hole eats. It's still a black hole, and a black hole is described by its mass, its electric charge, and its spin. Doesn't matter. You have a black hole that eats a bunch of cats, and a black hole that eats a bunch of cheese, and from the outside world, they're indistinguishable. It doesn't matter, and it doesn't antimatter either. Great joke, Java man. There's a question here. Remember, in chat, use the question mark thingy so that Nancy can flag it and move it over to the back channel. It says, this is Thaddeus. I don't believe in aliens, but my mom thinks they are real. Are they? It is. We have absolutely no evidence for any aliens. We have absolutely no evidence for any life outside the Earth, period. It is a big universe, however. I like to think that there are other intelligent civilizations out there. It'd be kind of a bummer if we were all alone and it's all for us. So just to make the universe a little bit nicer, I personally think that there are aliens out there, but they have not visited the Earth. They haven't, because time and space are huge. And even if we're not alone, even in our own galaxy, we're effectively alone because of the vast time and distance scales. Stars are too far away from each other. It takes forever to do anything interesting. If you're interested in alien, you remember Avi Loeb's book that came out earlier this year, Interstellar? And do you remember my reactions to that book? Well, the editors of Inference magazine, it's a journal, a science journal. They reached out to me for a book review, and I did a formal book review. Hence, it took 6 months to publish, but finally came out. Links are on my website, pmsutter.com. And yeah, I was not impressed by the book. Actually, the book was a horrible book. Sorry. Avi did not make a convincing case that he's the one who said that Oumuamua, this rock that cruised into our solar system, was a alien spaceship. Yeah, I mean, when you say that out loud, it doesn't sound so good. When you say that out loud, it doesn't sound very scientific. But yeah, he thinks it's an alien spaceship. And he tried to argue the case. He made a very bad job of it because he misrepresented and misunderstood almost every single bit of data we have about Oumuamua. And then he kept going on and talked about so many other random things that had absolutely nothing to do with. Yeah, Larry, Avi Loeb is so Avi. So Avi. Here we go.
Hi, my question is,
Hi.
Do black holes cast gravity wave shadows? Thanks, guys. You rock.
There's just one of me, but it's cool. It's cool that you think there's multiple guys. It's me and Nancy. Nancy is running the back end. She does the social media posts. She monitors the chat to keep the Space Cadets in line. But it's me. I produce this entire show. I've got my camera right here. I got my microphone right here. Got my laptop running the stream. What was your question? Do black holes cast gravitational wave shadows? Yeah, but black holes are small. But they also, actually, I'm thinking of this question as I'm trying to answer it as I'm figuring it out. Yeah, kind of, sort of, because they bend the path of light. They bend gravitational waves going around them, but black holes themselves are so small. Sure, they probably do to some degree. That's my answer. Another one from Jeff, and we'll eat some cheese.
Hello from Nashville, Tennessee. A question. Hey. When the Webb Space Telescope comes online, will you be able to image an exoplanet around Proxima Centauri? Thank you.
Yeah, James Webb set to launch December 18th, I think, if it's right. Currently set to launch, don't hold your breath for that date. Will it be able to image a planet around Proxima Centauri? This is the planet, the closest known exoplanet, because it's a planet around the next nearest star to Earth. Nope. So today's cheese, don't worry, guys, we're not stopping. Usually the cheese comes at the end, but today the cheese comes in the middle. And I figured, and again, this is from my good friends at Dom's Cheese, DOMS Cheese. Seriously, Space Cadets, get in your orders. They do ship. Pick up the phone and call. And get a lovely, lovely selection of cheeses that they have hand curated from around the world. Today's cheese smells awesome, looks awesome, has a fun name, Drunk Monk. This is a Trappist-style cheese from Belgium that has been soaked in beer, so I figured it'd make a good toast, right? There's no beer remaining in the cheese because, there's a rind and everything. But let's give it a shot, shall we? Cheese in the middle, the rest is bread. That's called a sandwich. That's so yummy. Cheers, guys. Don't worry, I'll keep eating the cheese. You know what? It's better than the Yay Toast, but that's a pretty low bar. It's better than the penicillin gorgonzola I had that one time. I'm not sure if that penicillin gorgonzola almost killed me or gave me advanced immunity to COVID. It was either one. Very binary. This is an awesome cheese. If you just want cheese, You know when you just want a large volume of cheese, like more than usual, and you want it to be easy and not complicated and just really nice, but like you don't want to get great value brand Monterey Jack because you'll just feel there's something wrong about that, about eating the whole brick. Get yourself, a good quarter pound of Drunk Monk. And it's going to be a great cheese. You're going to enjoy every bite. It goes down smooth and refreshing for half the calories. Oh, let's go. Voicemail.
Hey, Paul. Campbell from New Zealand here. Hey, I can't get my head around Hawking radiation. If two particles were to pop out of quantum soup right beside a black hole, how could one possibly have the energy to not get sucked into the black hole where the other one does? Thank you.
Hawking radiation. Hawking radiation. Oh, Rebecca. Hi, this is Ro. Can you recommend a good book on astrology for young adults? I think you mean astronomy. If so, I'm going to go get it. I literally wrote 2 books. I wrote 2 books. They're in Barnes & Noble. They're on Amazon. I'm just teasing you. That's family, by the way. I'm allowed to tease them. So, Hawking radiation. Guys, Hawking radiation is the most confusing thing in the world to describe. Because it's one of those things where like, how do black holes emit particles? And Stephen Hawking's like, through his robot voice, saying, oh, well, you have the quantum foam, particles pop out of the vacuum, particle and antiparticle, usually they annihilate and go away. Sometimes they don't. One falls into the black hole and the other escapes. And then you have this particle now all of a sudden existing in the universe. Someone has to pay the price. And it's the black hole, so it loses mass. But then you're like, wait a minute, one particle went into the black hole. So it gained mass, so shouldn't it all even out? And it's like, it's so confusing. Stephen Hawking, but like that description doesn't match up with the actual math of his 1976 paper. The 1976 paper they wrote, it was more about when black holes are formed. When they are first born, sometimes there are quantum fields that hang out near the event horizon, and they're so close to the event horizon that you think the black hole is all there, but then eventually they escape, and so the black hole is smaller than you thought. So I like to think of Hawking radiation as an artifact of the formation of black holes rather than something that happens to a static existing black hole. I don't know if that's any easier for you or not. It's just a crazy math thing that is hard to describe with words. Let's go, Marc.
Hey, Paul, I want to get your blood boiling a little bit so you can go on one of your famous rants, period. Have you heard or seen Avi Loeb's new article in Scientific American where he postulates that UAPs could be somehow linked to Oumuamua? Question.
I mean, she's to calm myself down, which I know is not a healthy habit, to regulate your emotions with food. I have multiple complex thoughts surrounding this. One, I'm going to tell you some of that, like, I write articles. I work with some great people. Scientific American has never once accepted one of my pitches. Never. And in fact, well, what they usually do is they're like, great pitch. And I send them samples of my other writing, and then I write and I write the article and I send it, and they go, they've said my writing is not serious. One article I wrote that I sent to them, they said it looks like it belongs in a children's magazine. That was a fun comment to get. Scientific American is a great publication. They have never once let me write for them. So that's funny. So it's funny. It's funny to me. It's amusing. And this is my last episode, so I'm going all the way off the rails. It's funny that they will, and it's like a normal article. I'm like talking about the relationship between space and time, or the positioning of science within society, like real stuff, using my normal voice, using my conversational approach that I do for everything. They have never once run and accepted one of my articles. But then Avi Loeb can say, I'm going to go ahead and say this, something as idiotic and nonsensical as UFOs are real. And probably prefacing it with, I am Harvard astronomer, former chair of the Harvard Astronomy Department. He's not chair anymore. And hey, you know what? You're hearing about these UFOs? Yeah, I told you aliens were real. And it's so gross how he operates, or how I see him operate, where whatever's in the news, he's going to loop back to something, to him, to one of his books, one of his ideas. And to say that UFOs, which I'm just going to keep calling them UFOs, I'm not switching to UAPs, I don't care, is connected to Oumuamua, which is connected to light sails. And by the way, he's on the chair of the Starshot Breakthrough Initiative that they're trying to make a light sail. Avi Loeb in his book Interstellar says that scientists need to get out in the media more. His big paper on Oumuamua, or the sensational paper on Oumuamua, he's the second author. I challenge any of you, without looking it up, to name the first author of that paper. Well, it was his grad student who actually wrote the paper. Have you ever heard from that graduate student? Have you ever heard from that person? Scientists need to get out more as long as they're named Avi Loeb. I'm sure the Space Cadets... James Webb, would it be great for a search for Settle? I just released a YouTube video, search for extraterrestrial intelligence. It's time to end SETI, because it's weird. We're not even sure what we're looking for. We're not even sure what we're doing. We don't know what a signal from an intelligent civilization would look like. So maybe we should, instead of searching for intelligent life, we should just search for life. So we should just do the search for extraterrestrial life, which is SETL. So maybe we should settle for something more reasonable. James Webb, would that be great for settle? Yes, it would. James Webb is designed to look for exoplanets around other stars and study their atmospheres and look for signs of life. John Anderson, how do you feel about Donald Huffman's take on conscious agents rather than physical objects in space-time fundamental? I've got nothing to say about that. I don't even know what it is. People have all sorts of interesting ideas. Maybe it's an interesting idea. Maybe it's not. Java Man, is there one big question you would ask an advanced extraterrestrial? Yeah, what do you think of Avi Loeb? We'll go there. I'll just, if we met aliens, I don't know, I'd ask, like, what's the nightlife like on your planet? What do you do for fun? Have you heard of cheese? I can be a cheese evangelist. I'll do that. I'll spread the good word. I'll have another slice. We should have a show like, go back and listen to old episodes, and every time I rant about Avi Loeb, you take a bite of cheese. CDP, how far do you think physics is from finding a theory of everything? I think we are either 3 years away or 300 years away. Or like 30 years away or 300 years away. Actually, I don't know if we'll ever find a complete theory of everything. I really don't know. The universe is under no obligation to make sense. The universe is under no obligation to provide us with a theory of everything. The universe is under no obligation to be tractable. We may never figure it out. We may be barking up a completely wrong tree. I remember when I recorded the latest season of How the Universe Works, there was a question about dark matter, and they said, in the episode, we review the different possibilities for dark matter, and it's a pretty fun episode. At the end, they asked each of the contributors, what do you think is the best answer? What do you think dark matter is? And I said, none of the above. Dark matter is there. We know it's real. We're missing something. I don't know what it is. Jack Burkholder, are we in the universe itself really just in a simulation? I think I'm going to tackle this in an upcoming Ask a Spaceman. Which, by the way, my YouTube presence is not going away. I'm still doing my pre-recorded videos, dropping every other week. Ask a Spaceman. And I want to talk about the simulation hypothesis, which is an interesting philosophical argument. It's not a physics argument. I usually don't tackle non-physics or science questions in the show, but sometimes I do. No, we don't know. And the simulation hypothesis, which is, okay, let's say there's a universe and they make a simulation that is able to replicate everything going on in the universe. There'd be little intelligence inside of that simulation, and then they would make a simulation, and you have this infinite chain of simulations. And so the likelihood of us being in one of those simulations rather than being in the OG universe goes up with the number of simulations. That's not how to do probabilities. It's mathematically nonsensical, that kind of statement. You have to assume that the probability of being in a simulation is equally weighted to being in the OG universe. And so that's an assumption. So it's basically, my view of the simulation argument is if you assume that we are in a simulation, then we live in a simulation, which isn't as strong as it sounds when you wrap it up in all the technical language. But I'm going to do an episode on it. I don't know if we are in a simulation or not. It also doesn't matter. And there's also no way to tell. And the arguments saying that we aren't very good arguments. Alan, but what if you live underwater? Would a red dwarf blasting a planet matter more than a few meters? Yeah. If you're a planet orbiting a red dwarf and you're getting blasted, yeah, you might have subsurface life being just fine. Okay, have fun with that. Have a great time. Fifth dimension. They've just found a number of newly detected galaxies way out there near the edge of detectability in the infrared. Does this mean the universe has far more matter in it than we thought possible? No. We have mapped less than 1% of all the galaxies in the universe. So finding more galaxies, we're just adding to the percentage of the total that we know is out there. We have strict limits on the amount of matter in the universe from our observations of the cosmic microwave background and from our observations of what's called the Big Bang nucleosynthesis, which is the formation of light elements in the early universe. If you start messing with the cocktail, with the recipe, with the ingredients in the early universe, you end up with different amounts of hydrogen and helium, different relative amounts, different amounts compared to the amount of radiation in the universe. You just start messing with everything. So we have big handles on the total amount of mass in the universe. Larry, could the Big Bang be considered a white hole? No. Majestic Potato, can we feed our sun to keep it from dying? Whoo, boy, that is like the last thing you want to do. If you take a star and it's fusing and it's happy, it's having a great time, and you add more material to it, that's more mass, that's more gravity, that is increased pressure in the core, that increases the rate of fusion reactions and shortens its life. This is why the big stars will last 10 million, 100 million years, while the small stars will last trillions of years. So if anything, if you want to extend the life of the sun, you need to take stuff off of it. You got to lower the pressure. Definitics. I'm doing a book report for my class and wondering if the book Billions and Billions by Carl Sagan is a great read. I don't know. I've never read. Honestly, so I'm really fun at parties here, folks. I was, as a kid and a youth, I was never really drawn to Carl Sagan or Cosmos. Actually, when I was a kid, the TV show that I would watch over and over again was James Burke's Connections. It's always fascinating. I have a couple of James Burke's books on my bookshelf over here. Always fascinated by that. That's what got my juices flowing. I love space and astronomy, but Carl Sagan's presentation, his books, Demon Haunted World, I saw mentioned in the chat. I actually have some issues with that because it presents science as like this ultimate answer to religion and superstition, which is nonsense when you look at the history of science and the relationship between scientific inquiry and other forms of inquiry. I don't know. I have another suggestion. Slide it into your camera right here to do a book report on. I'm just saying your place in the universe. Understanding our big messy existence. My title for this book, for those of you who know, my title for this book was You Are Not Special. Barnes & Noble didn't like that title. They thought it was too depressing. They're right. SAHM, is it possible to sync all the antennas using a pulsar? These are, no. Nope. Procyon. What's your shirt? This is a shirt, Vanderbilt Observatory, the Dyer Observatory at Vanderbilt University. It's just a cute little spacey shirt. I got it when I was on my book tour a couple years ago for How the Universe, Your Place in the Universe. I never got a book tour for How to Die in Space because, this minor thing called the pandemic. I visited, they gave me a t-shirt. It was super cool. I like the shirt. I like how it feels. Howard, do you think life on Earth would have developed without the moon's gravitational pull stirring things up? Yeah, actually, because there's this question. We're not, as far as I understand it, the question of abiogenesis and the origins of life, we might have developed, life might have developed in tidal pools. It might also have developed in undersea vents. It's a little unclear, at least my understanding of this issue, what the origins are. So yeah, that's a big maybe on that question. Larry Beckham, I heard this morning that Hawking ray radiation has the wavelength of black hole diameter or circumference. Sure. Infinite Monkey, are primordial black holes real? Will we ever be able to confirm their existence? Primordial black holes, PBHs, by the way, fashionable for a while, then totally unfashionable, then ruled out by experiment, except for a very, very narrow mass range where observations, were a little bit inconclusive, but generally tough. And so people are like, okay, never mind. We don't need to worry about primordial black holes. Interesting idea, but not everyone can be a winner. And then LIGO comes and says, hey, look, we got these like big, but not super giant black holes. And we're like, how do you get black holes? How do you get a black hole to be 50, 60 solar masses? Or a few hundred solar masses? That's weird. Primordial black holes came back into fashion. Generally, though, it's tough. It's very, very, very tough to have primordial black holes in our universe because, one, we're not even sure how we would make them. So you need crazy physics. And then two, there are all these observational tests, and they don't pass them. Let's go back to the voicemails.
Hi, Paul. Steve here from the UK. I have a question about spinning. Everything spins. The sun spins, the planets spin, the planets rotate about the sun. I've heard an explanation that this is because the solar system formed from a cloud of dust and gas. Mm-hmm. And as this cloud condensed and reduced in size, it had to spin faster and faster. I find this unsatisfactory, as it merely moves the question elsewhere. Why was the cloud spinning? If it were made up of random particles, then the net spin would surely be 0. Can you help me to understand this? Thanks, Paul.
Well, I'm sorry that the universe is not satisfactory to you, Steve. But check this out. If a gas cloud were made of random particles with random trajectories, what are the chances that the average spin, the average momentum, the average movement of all those particles would cancel out to be perfectly, identically 0? 0 is the answer to the question of how likely would it be 0. There'd be some little tiny net spin. All it would take would be one atom moving in one direction extra for a second for the net spin, once you add up all the momenta of all the particles of that entire gas cloud, to be spinning just a tiny bit, because it won't perfectly cancel out. And then you take that tiny little spin, and as soon as you start collapsing, that tiny little spin gets inflated and you're off to the races. Satisfied now? Oh, I guess not, because you have another question.
Hi, Paul. Steve here from the UK. I've been thinking about the effect of gravity on quote-unquote massless particles. If we direct 2 parallel beams of light into the void, would they, in theory, eventually converge due to their mutual gravitational attraction? Thanks, Paul.
I mean, yeah. Well, it's complicated and nuanced. Massless particles, like the photon. Under normal circumstances, most situations that you're going to think of, they don't exert gravitational attraction of their own, but they do respond to the gravitational force of other objects. But a photon does have energy, and in general relativity, its mass or energy contributes to the gravitational field. So yes, a photon does have a tiny little bit of gravity. It is so vanishingly small, it might as well be 0, but it's not. So yeah, you send out 2 parallel light beams, and you waited, 10 to a quadrillion years. They might eventually converge. Okay, good question. Anonymous. Oh, these are the tricky ones. These are the people who didn't bother to type in their name. These are the ones that get scary.
Hi, Paul. Steve here again from the UK.
Oh, it's just Steve.
With Space Radio coming to an end, I'd like to take the opportunity to pay tribute on behalf of all the Space Cadets. Space Radio was such a wonderful concept, engaging, human, interesting, and accessible. Of course, we'll be sad to see it go, but looking to the future, we're also excited about what's to come. Whatever your new venture is, please include the facility for us Space Cadets to continue to ask questions. I have 1,000 more questions stacked up in my head. The way you explain astronomy and cosmology and make them comprehensible to the layman is unparalleled and seems to be a consequence of melding your obviously profound knowledge with your superb natural aptitude for clear communication. So, on behalf of Space Cadets everywhere, thank you, Paul.
Thank you, Steve. I really do appreciate that. You've offered so many great questions over the years, and this is a joy. It's a treat to hear the questions from the Space Cadets every week. Engage with you, talk with you. I love doing live shows, not just live stream. Live in-person events are my favorite. Getting to connect with an audience, talk with an audience. So I will miss you, Space Cadets, but I don't want to cry. Oh boy. Let's do another one.
Suck my dick, I fuck to beat, yo girl. Is there music out there? Yeah, girl.
Mm-hmm. Get back to class.
2-part question on the CMB. First one, let's say if you could look at the CMB, say 1 billion years ago, and you could stare at it for, say, 1 billion years straight, so 1 billion years into the future, would the patterns in the sky change through time, or would they just remain the same and fade? For example, like, let's say if there's a Barionic ice, I think it's, let's say there's a pattern in the sky where you believe it's related to part of the isolations, Barionic isolations. Would we kind of see that grow and shrink as that bubble kind of slices through time? That's question number one. And then question number two is, let's say you could time travel. You could go back, you could look at the CMB, say, 1 billion years after the universe was created, 500 billion, or say 5 billion years after, 10 billion years after, and then you could look at it, say, 100 billion years from now. What would the differences look like?
Yeah, these are both very, very good questions. So the cosmic microwave background is a snapshot of the light that was emitted at that particular time from that particular part of the universe, finally now reaching us. If we were to stare at the CMB for billions of years, it would change, because light that released the cosmic microwave, or the part of the universe that is just a little bit further away, when it released its cosmic microwave background, would reach us. So yes, the patterns would slowly shift. The statistics would stay the same, which is what we base our cosmology on. But the individual splotches, the cold and hot spots here and there would change, because you'd be getting a snapshot of different parts of the universe. Generally, though, the temperature of the cosmic microwave background is dropping. When it was first released, it was white hot. It was around 10,000 Kelvin. Now it's just a few degrees above absolute zero. It will continue to get colder in the future. It will continue to stretch out to longer wavelengths. Eventually, it will become undetectable. And if you were to go back to just 1 billion years after the Big Bang, you would see a warmer, hotter, and shorter wavelength CMB mapping a different part of the universe. Hope that helps. Another one from Alan.
Hi, question number two. Let's hypothetically say that it was possible to see neutrinos with good resolution, and someone were to look at the Earth. What would they see if they looked at the Earth? Would they see all of the nuclear power plants? Would they see all the ships with nuclear power plants in them? Would they see CERN? Would they see Fermilab? Which would be the brightest objects on the Earth? Thanks. Bye.
Yeah, this is a fun question. Let's say you could see in neutrinos. What would your universe look like? The number one, by far, emitter of neutrinos is the sun. The neutrinos are emitted in nuclear reactions, and the sun is mega nuclear reactor, is flooding our local patch of space with neutrinos all the time. So that is what you see. But if you're to block that out, the number one source of neutrinos would be radioactive decay in the center of the Earth. This is happening all the time. The Earth was born with radioactive elements. They are decaying all the time. They are releasing neutrinos. So that'd be number one. You would see, on top of that, you would see hotspots, the nuclear reactors, any mined nuclear material that's just hanging out. You get to see that. But by far, the biggest source would be the natural ones. All right, is this it for the calling question? Oh, no, I got more. I got another one from Steve. But first, Howard.
Hey, could you please explain what is meant by escape velocity? Does an object actually have to hit a certain speed to escape Earth's gravity? And if so, why? Why couldn't something go slowly up as long as it has enough power to continue pushing up, slowly? Why does it have to go fast to escape? Thank you so much.
Yeah, that is a good question. There's this misconception about escape velocity, which this question directly gets into, which is escape velocity. We calculate it, I forget what it is, like 27,000 miles per hour from the surface of the Earth. That is from the surface of the Earth. If you want to escape the Earth right now, do it once and do it for good, you need to power up, reach that speed, and then you're golden. You can shut off your engines and you will just coast and coast. You will coast along and you will eventually escape the gravitational influence of the Earth. That's it. It is possible to escape the Earth by going slowly, but you have to keep accelerating. If you go 5 miles an hour, let's say you launch yourself off the surface of the Earth at 5 miles per hour, and then you do it for an hour and then stop, the gravitational pull of the Earth will just bring you back in eventually. Let's say you go 500 miles an hour and you do it for an hour, you'll get a little bit further and then the gravitational pull will bring you back. Let's say you go 5,000 for an hour, you'll do it for a while and then you'll come back. But if you're able to hit 27,000 miles per hour, even for 1 second, you are good. The Earth will never bring you back. So you can go slowly, but you have to accelerate. So if you start off going 5 and you keep that engine going, and then you go up to 10, and then you go up to 15, and then you go up to 20, and then you go up to 25. Eventually you will escape. It will just take you a really long time. So it's not about going slowly, but it is possible to accelerate slowly, and eventually you will leave. Let's go, Steve. I think this is the last voicemail.
Hey, Paul, Steve from Utah here.
Different
hey,
Steve.
So what are your 2 most frustrating misconceptions that you hear from people either on a daily basis or, what are the most common ones that just really frustrate you? Thanks.
One, yeah, you're welcome, Steve. Thank you for being a different Steve. No, Steve, all Steves. We are a friend of all Steves on this show. Number 1 is a movement. I'm just kidding. I actually don't get frustrated at people's misconceptions. Why should people know any of this space stuff? It doesn't impact daily life. It doesn't help pay the bills. It doesn't make your kid not be sick anymore. It doesn't fix your car. The space stuff is for fun. And so I don't get frustrated when people don't know about the structure of the solar system, when they aren't sure what a black hole is, when they heard about a wormhole on a TV show and want to get curious about it. I don't get frustrated because when people ask me questions or I encounter people, I was at a dinner party Tuesday and very smart, very well-educated people were asking me if UFOs were real. I didn't get annoyed because they're curious. And to ask a question is to open up a vulnerability. It's to admit, hey, this guy seems to know what he's talking about. I'm going to admit that I don't know what I'm talking about, and I'm going to ask. So when people come to me with open, honest questions, I never get frustrated, even if it's the same question again and again and again. What I get frustrated by is when people ask a question and I give my best answer based on all of our scientific knowledge, and I bring it all to bear, and I try to make it accessible and interesting. And then they tell me I'm wrong, or they say, well, I don't believe that. Or you've got, any number of reactions. I don't expect people to just believe me because I say it's true. But when I give an answer, it's like I try to fold in the evidence in the scientific rationale. And then just to dismiss it out of hand and say, well, I don't believe that. That does get frustrating to me because I was like, why'd you bother asking? Did you ask just so you would have an argument? Did you ask? I posted this story on my blog, pmsutter.com/notes. I don't talk about my blog much, but I also posted it on social media. We had a squeaky dryer, so we got a repair guy. He came in, he fixed the dryer, but although not really, it still squeaks. But that's a different thing. And he asked about this. Somehow we started talking. And he asked me about the Silurian Hypothesis. This is the conception that there have been past intelligent civilizations on the Earth, but they've been buried by all the geologic turnover, and so we have no evidence for them. This is not a serious biological theory. We have very good records. And he talked about this, and I mentioned, I'm a scientist, I'm an astrophysicist, I'm aware of this. In fact, the Silurian Hypothesis was proposed by astrophysicists as a thought experiment about the detectability of extraterrestrial life, not as a serious proposition for the history of the Earth. And I said, well, it's, paleontologists, biologists, we have a really good understanding of the evolution of life on Earth. Yes, there are gaps in the fossil record, but not the ones that big. We've charted the advance from single-celled organisms to multicellular. And he's like, was like, well, why'd you ask? Fifth dimension, they've not found the fourth neutrino yet. Nope. Kuplex, what do you think about KIC 8462852 and the deep periodic dimming events? I don't know. It's a weird star. Like, nature is weird. I need some cheese. Nature is weird, folks. Stop pretending. Oh my gosh. The tabby star stuff got me all up in a tizzy. Nature is weird. Just when because you see, and this is best delivered with mouthful of cheese. Just because you see something weird happening in nature doesn't make it aliens. Come on. Be more creative than that. We're smarter than that. It's so lazy. Which was my first criticism. When Avi Loeb said Oumuamua was a spaceship, I said, that's just lazy. That's not creative at all. That's not thinking creatively. That's not thinking critically. That's just saying, I don't know what it is, therefore it's aliens. Come on. We're better than that. SAHM. What if we find intelligent life and a hospitable planet, but their whole DNA, proteins, and organic molecules had opposite chirality of our molecules? Yeah, this is the coolest thing. Molecules can arrange themselves left-handed or right-handed, chemistry. These have the exact same functions, do the exact same thing. It turns out all life on Earth is left-handed. Not left-handed as in you used your dominant hand, but all your molecules, the way they twist up on themselves, are all left-handed. That'd be cool if it had opposite. I mean, it had to be one or the other, and we got lefties. Al Nalam, the space in between is missing. No, it's right there. Right there. Larry Beckham, so lithium does matter. No, lithium will never matter. Long-running joke between me and John Michael Gaudier. Steve, what is your end-all, be-all argument against flat earthers? Take a long walk off a short pier. No. I have no argument for flat earthers. They did not arrive at their conclusions from a careful reading of the evidence. They didn't get there from the evidence. So me being scientifically minded, evidence-minded, is not going to convince them. I just changed the subject. I'm not interested in that debate. I'm interested in why. I'm interested in why they believe the earth is flat, and I'm trying to understand the causes behind that, but no. Gorilla on YouTube, can you talk to us about sterile neutrinos? Yeah, we've got 3 neutrinos that we know of. There might be more neutrinos out there. They're called sterile neutrinos. That would be even harder to spot. There might be 1, there might be 1,000 of them. We don't know. William Black, will the back episodes of Space Radio remain available on YouTube? Seriously, Paul, thank you for the amazing Space Radio. Thank you. You guys made this show possible. It was your questions. Yeah, all the back catalog will still be there in the podcast version as well. Could we escape a black hole event horizon if we keep accelerating? As long as you don't cross the event horizon, you can escape. The escape velocity of a black hole at the event horizon is the speed of light. That is the definition of the event horizon. As long as you haven't crossed it, if you're a nanometer above the event horizon, you can in principle escape. You just have to accelerate close to the speed of light. Zachary, does the math say that time is moving backwards inside the event horizon of a black hole? My question is only about the math. I understand the practical application would not be practical. Yeah. No, time does not move backwards inside of a black hole. Time still ticks forward. But what happens inside of an event horizon is that your future is locked. So outside of an event horizon, you can go anywhere you want in space. You can pick any direction, anytime you want. Inside of a black hole, you must go to the singularity. All roads, all directions, no matter where you turn, the singularity is in front of you. And you cannot be still inside of a black hole. So as time marches forward, you get closer to the singularity and there's nothing you can do about it. SAHM, what if we find alien life and we realize that a specific sci-fi writer had it completely right? I mean, we've written enough sci-fi stories. You throw enough darts at the dartboard, someone's going to nail it. I think that's it, folks. I didn't think it would come to this. I was hoping... Yeah, what happens inside the event horizon stays in the event horizon. It's the ultimate Vegas. This is it. For Space Radio, a 4-year journey, close to 200 episodes. Maybe 250? No, close to 200, because 4 years, there's only 50 weeks in a year. So somewhere between 150 200 episodes of Space Radio. I don't know how many questions I've answered. I don't know, a couple thousand questions. 90% of them about black holes. I don't know how many rants I've gone on. Probably 200 rants. This has been a journey. This has been a real voyage. This has been a treat to engage with you guys every week. I'll probably pop in for live things every once in a while. I'll try to give some advance notice on my social media. Like I said, follow me on all social channels. I'm at Paul Matt Sutter on all channels. Facebook, Twitter, Instagram, TikTok. That is your best bet for keeping up to date with the articles I write, with books that come out, with work I do, projects. I'm going to miss the Space Cadets. If you want, you can contribute to patreon.com/pmsutter. Now is your last chance to drop a super chat if you want. I really would appreciate it. I still do live stuff. Ask a Spaceman, I still do without compensation. I do have sponsors, but trust me, it's not a lot. I do it for fun. Ask a Spaceman podcast and YouTube show are going to continue on for a very, very long time. That is totally fan supported. And I get 2 podcast episodes and 2 YouTube videos out every single month. And I have for almost 7 years now. This is a bittersweet moment because I decided to end this show so that I could open up some new opportunities. And I'm excited for the new opportunities. I know this is the right decision, but the right decision doesn't have to feel good. This doesn't feel great to end this tradition. I hope you carry the spirit of Space Cadets. I will still call you my Space Cadets wherever I go. I hope this has been as much fun for you as it has for me. I hope all of you stay curious. I hope all of you keep asking questions. I hope all of you stay in love with the same universe that I am. I hope all of you buy my books and follow me on social media and all my platforms. I hope you just enjoy yourself and enjoy your life in this universe. Thank you for joining me on this voyage of Space Radio. Thank you to Nancy Graziano for wrangling the Space Cadets all these years. Thank you again, Space Cadets, for listening. And it's true, science is for sharing. Please keep that in mind. Anytime you encounter science, it is meant to be shared. And I hope you share that love of science and love of curiosity and love of the universe that we find ourselves in. Science is for sharing, and